So we are going to see a numerical based on mass and weight. Okay. So the numerical is, means the example is given that the a person is there and the weight of the person on earth is 750 Newton. We know the Newton is the unit for weight. So weight is 750 Newton on earth. So the mass of moon is 1 upon 81 times that of the mass on earth, and that is, we can write mass of moon upon mass of earth is 1 upon 81. Another thing is given that radius of moon is 1 upon 3.7 that of the radius of earth. So we can write radius of moon upon radius of earth, side change, and then it becomes at a denominator, and the ratio is 1 upon 3.7. So we have to calculate what we have to calculate. Weight on moon is equal to how much? So we have to calculate the weight of the person on moon. So here we don't know. For weight we should know the value of m and g. So we will consider the mass of the person. Let the mass of the person be m. So the value of mass of the person is not given, so we have to consider it as a m. So we can calculate the mass of the person as it is, as like this. So weight on earth is equal to mg. So we know that formula for force. Weight is nothing but the force with which earth attracts the things. Force and weight both are is equal to mg. So up below that, weight on earth is 750 Newton, m as it is. Instead of g, we can write the formula for g. So gme upon re square is the formula for g. So again, for by side changing the side, we can get the value of m, because we don't know the value of m for calculating the weight of the person. So change the side now. So this numerator, this denominator re goes in the numerator by changing the side, and this values goes in the denominator like this. So m is equal to 750 as it is, re square, radius of earth square, upon g, moon, mass of the earth as it is. So we have to use this value, because we can use this value for weight of the person on moon also, because we know that we have just seen in the derivation, the explanation, mass of the person or mass of the object remains same from one planet to another. As we go from one planet to, on all planets, mass remains as it is. So we have to give it as the equation number 1 and use this value ahead in the example. So we have to calculate the mass of weight of the person on moon, and same formula mg. Instead of g, we can write gm upon rem square, mass of moon on mass of radius of moon. We have to consider for the value of g on moon. So we can write weight of the person on moon is equal to m gmm upon rm square. So from equation 1, we can write that mass of m is from equation 1. So this value we can write here into gm upon rm square as it is. So as g is the universal gravitational constant, therefore it get cancelled, and we can get 750 into radius of earth upon radius of moon whole square into mass of moon upon mass of earth. So 750 as it is, we know the ratio of radius. Radius of moon upon radius of earth is 1 upon 3.7, but we have to take radius of earth upon moon, we have to reverse this value. So therefore we can take 3.7 whole square into mass of moon and mass of earth. Ratio is given, it is 1 upon 81. So we can write 1 upon 81 as it is. So no need to reverse, because it is given as it is. So mass of moon upon mass of earth is 1 upon 81, and then we have to multiply all the numerator things. So multiply this 750 into 13.69, and upon easy calculations are given here. You can zoom the video. So 3.7 square of 3.7 is 13.69. 13.69 into 750. So 13.69 into 750 is 1026.4.50, because point is after 2 digits. So 0.50, and then we have to take this and we have to divide this value by 81, because there is a new denominator 81 is there. So it is division is given here. Divide 81. So for dividing the first this number 102 by 81, we have to consider the table of 8. So 8 ones are 8 for 10. Similarly, we can take 81 ones are 81 for 102. So we have taken 81 ones are 81, and then 21 is the remainder. So then the 6 as it is, from above we can take this 6 as it is, and this value is 216. So how can we divide this value by 8? First we will see the table of 8. So we can take 8 to the 16. Similarly we can take 81 to the 16. फर्स्ट आपण 8 चा टेबल बघायचा. मग 8 च्या टेबल मध्ये आपण 8 नी 21 ला डिव्हाइड करू शकतो, म्हणून 3 डिजिट नंबरला 81 नी पण 2 नी डिव्हाइड करायचं. मग 81 टू जा आपण इथे कॅल्क्युलेट केलं, 81 टू जा 162 ऍज इट इज घेणार. मायनस केल्यानंतर जी व्हॅल्यू येते ती आपण ऍज इट इज घेणार. परत एकदा तसंच करायचं. 8 चा टेबल घ्यायचा. आता 8 चा टेबल घेतल्यानंतर 8 6 जा 48. देअरफॉर we can take 81 6 चा व्हॅल्यू जी काही येईल ती इथे घ्यायची, आणि then we can minus it, and finally we can calculate the answer. Point as it is, and the after point we can take after only one digit is enough after point. Therefore 7 is repeated, you can make it as a 8. You can calculate the. So the weight of the person on moon is equal to, we have calculated this, we have made this value as a divided by 81, and then we have divided by 81. The value is 126.7 Newton is the weight of the person on moon. So we have to consider here the same thing, that mass remains same, mass of the object or person remains same from one planet to another planet. As we go from one planet to another, mass remains same, and we can use the same mass value of mass here, and thereby we can calculate the weight of the person on the moon. So this is about the numerical given in the your text.